All right, so let's take a look at Unit 1, number 16, the Unit 1 review. So we've got a temperature problem. Let's see. Sam's preheating the oven while prepping cookies. Oven starts at room temperature. Takes 8 minutes to reach 350. Time and temperature are linear. What would the temperature be in another 4 minutes? Okay, so let's see here. We could do this a few ways. One of the ways we could do it is, we need to figure out how it took 8 minutes to go from 68 to 350. So 350 minus 68. Let's see, what's that equal? Hold on. I don't want to do that in my head. 350 minus 68 is 282. So it heated up 282 degrees Fahrenheit in 8 minutes, which is the same thing as saying if I did 282 divided by 8, that's 35.25 degrees Fahrenheit per minute. So that's how fast it's heating up every minute. Okay, so what would the temperature be in another 4 minutes? Well, let's take 35.25, multiply it by 4, and let's see, that's 141. We were at 350 degrees, so it heats up another 141 degrees, and so that's going to be 491 degrees Fahrenheit. That's one way of doing it. Another way of doing it is to actually do part B first and then just know what you're supposed to plug in order to get the answer to A. So part B says, what's an equation that relates the temperature to the time? So we're trying to come up with some way of getting the temperature by plugging in a T over here, however many minutes it's been. Well, if you think about it, this right here is how much it heats up per minute, right? So this is the rate of heating, how fast it heats up, and we started at room temperature, right? So the room temperature, it's really like it's at time 0. When time is 0, what's the temperature in Fahrenheit? So at time 0, the temperature was 68. And at time 8, it was 350. And what we figured out was that if we did 350 minus 68 and divided it by 8 minus 0, we got 35.25. That means this thing right here is the slope, right? But if you forgot that, if you didn't realize that, you could still find the slope from these 2 points. It's really like an x comma y, right? But let's say you weren't sure about it. Well, okay, these are the x's, these are the y's. You could do y equals like this form, y equals mx plus b. In this case, it's f equals mt plus the y-intercept. And the m is the 35.25. And the y-intercept is 68, because that's where we started. So here's one way of coming up with that equation, right? Maybe using all the F's and T's are confusing, so we could just start out with Y's and X's. If you did Y minus, let's say you went with this form, right? Well, you can plug in one of those points. So I'd probably plug in the 0 and 68 because those are easier. So this one's the 0, this one's the 68. So it's y minus 68 equals your slope, x minus 0. Let's say, again, you couldn't remember how to do the slope. You can get the slope from here. It's y2 minus y1 over x2 minus x1, which is 350 minus 68 over 8 minus 0, which is really the same thing that we did up here. 282 divided by 8, 35.25. And then that's your slope. And really, I'd probably simplify that to y minus 68 equals 35.25 x, and you could just add the 68 over if you wanted, and you got the same sort of equation that you have up here. Now it says in terms of Fahrenheit and time, in terms of temperature F and time T. So you actually need this, the Y values of the F. So you need it to say F and T, not X's and Y's, right? So it's got to have the F's and T's in your answer. Part C says, how long will it take the oven to reach 425 from when it first starts? So from time 0. So we want the Fahrenheit temperature to be 425. So if we set that up in our equation, we could use this one or this one. It doesn't really matter. But this one already has F by itself. So F is 35.25 T plus 68. So if I solve that, let's subtract 68. So then we're going to get, let's see, what's 425 minus 68? That's 357 equals 35.25 T. And then if I divide by 35.25, I'm going to round this, 10.13 is about T. So it's about 10.13 minutes.